Good morning, students. This is Mr. Bauer. Um, this is lesson 1/8 that I'm going to be going over, and this lesson is on equations. Okay, let me go ahead and share the screen. Okay, hopefully you can see the screen quite well. Anyways, so in lesson 1/8, we're talking about equations. So I gave you a couple of definitions here to make this more clear. And I just realized it's getting a little bit dark here. I need to add a touch of light. Let me pause this for a second. Okay, I'm back. I turned on a couple of lights. Let me share the screen again. Hopefully this is bright enough that you can see it. Okay, so starting off, lesson 1/8 equations. The first definition I want to remind you of is expression. And I used the term expression earlier when we were talking about expressions, I think in lesson 1:1 and 1:2. Anyways, an expression is a number sentence with numbers, variables, and operations. An equation is a number sentence with numbers, variables, operations, and an equal sign. So in comparison, when you're just working with an expression, there's usually no equal sign. Like if you have 7 plus 2 plus 3, okay? 7 plus 2 plus 3 would be 12, okay? That would be an expression because there's no equal sign. Now, to make it an equation, if I said 7 plus 2 plus 3 equals 12, and then the sentence actually contains the equal sign, then it would be an equation. Now, there are two basic types of equations that we will be going over. There's arithmetic equations and algebraic equations. An arithmetic equation is typically written like this. 4 plus 8 is equal to something. Then I use a question mark to represent the something that we don't know. Obviously, you can figure it out pretty simply. An algebraic equation using the same number pattern would be 4 plus something is equal to 12. Now in this case, it's a similar problem. It's using the same numbers. The difference is, instead of 8, the number that should be next to or added to 4 is missing, but the number that normally would be missing in an arithmetic problem, the answer is listed, and that's 12. So the problem, if we knew everything, was 4 plus 8 equals 12. Now, here's a quick hint. I used a question mark instead of a variable, because normally a problem like this would be written as such. 4 plus, we'll just use the letter A, equals 12. Okay? So I used a variable. I just picked the letter A randomly. It could be any letter. Typically, you probably want to avoid the letter I or the letter O in a random variable just because those are, they look too much like letters. I mean, they are letters. They look too much like numbers. But sometimes you may have an equation that requires those specific ones, but I just wanted to let you know that. Okay. Continuing on our list here. Okay, so here's some typical equations. I have 2 plus x equals 5, x plus x equals 16, 4 plus 3 equals 7. Okay, now in the first equation that I mentioned here, 2 plus x equals 5. So you can pretty much answer this fairly simply and ask the question, 2 plus what equals 5? Well, it's normally 3. So in this equation, x equals 3. In this equation, x plus x equals 16. Now, one thing I know about equations is if a letter occurs in the same equation more than one time, that letter has the same value in that equation. Now, we call it a variable because its value changes. But in the same equation, x here is going to have the same value as x there. Okay? If it was in a different equation, it could have a different value. But within the same equation, x, or whatever letter you use, is always going to have the same value if it's used more than one time. So in this case, x plus x equals 16. Well, what would x have to be? I'll give you a second to figure it out. 1001. There's your second. All right, well, I'll help you. So in this problem, x is going to equal 8. Why? Because the only number plus itself that equals 16 is 8. X can't be 6 because 6 plus 6 equals 12. X can't be 7 because 7 plus 7 equals 14. X can't be 9 because 9 plus 9 equals 18. Okay? The only number plus itself that equals 16 is 8. Okay? Now I want you to notice something. With a variable, the value of x changed. In the first problem, it was 3. In the second problem, it was 8. Okay? But within the problem itself, it may have an unknown value until you figure it out, but whatever the value is going to be the same for this x as it is for that x. Now let's look at our third equation. 4 plus 3 equals 7. Now since there's no variable in here, there's no need for me to write down x equals anything because I don't have x in that problem. I just have constants. Now constant just means a number, okay? Now, let's take a look at this definition that's in your book, an open sentence. An open sentence is an equation with a variable. Hint, oops, I just dropped my pen. Let me pick it up here. Hint, it may be true or it may be false. Now, let me give you some examples. Let's take a look at this first one. 6x is equal to x if x equals 0. Now let's try. Now remember, when you have a number next to a letter, it's called a term, and the number next to a letter means the number times the letter, okay? So let's look back here. We said this is true if x equals 0, so let's find out. If I substitute 0 for x, then that would mean 6 times 0 equals, and the x was 0 again. Yeah, that is true. 6 times 0 does equal 0. Okay. Now let's look at this open sentence equation that is false. It's the same sentence again. 6x is equal to x. But the difference is, in this particular version of it, x equals 2. Well, let's find out. 6 times 2 does not equal 2. So this one would be false. So you notice in the false one, once I finally wrote it out, I changed from an equal sign to a not equal sign, okay? What does 6 times 2 equal? Let's see, I'm listening, and Aaliyah, you said 12. That is correct. Awesome, okay. So 6 times 2 equals 12, it does not equal 2. So in an open sentence, sometimes you can have a false equation, okay? Now another vocabulary word, which we had gone over earlier, is the word solution. Solution simply means the answer to an algebraic equation, okay? Now I want to remind you of the other words that I had put when we talked about this first. There was sum, difference, product, and quotient. Now these are the names of the answers in all 4 operations. Okay, but the answer to an algebraic equation is called a solution. Why not give it another fancy name like sum or difference? Because a solution could have a sum, a difference, a product, and a quotient all in one problem, okay? So solution, it just means that it's like a little bit of everything. Now in the work that you'll need to do, you'll need to know the vocabulary that's mentioned here, but just so that we're clear, you don't really have to solve a lot of equations in terms of solving them algebraically. It's more of like problems like this one, where you ask the question, 4 plus what equals 12? Well, I think 4 plus 8 equals 12. Problems where you can kind of look at and figure it out. 2 plus x equals 5. 2 plus what? I think it's 3. So 2 plus 3 equals 5. Okay. Hope that that makes everything clear. And thank you very much.